Well, it's lovely to see you all here. I'm really excited for today's session. Welcome to everyone to the RPF, the Raspberry Pi Foundation Computing Education Research Seminar. My name is Jane Waite and I'll be chairing today's seminar. I'm very excited today to welcome you to our 8th seminar in our series on teaching programming with or without AI. In this series, we're kind of looking at new approaches on teaching programming at school, but often we're learning about that from undergraduate contexts. And we're exploring research that people from all around the world have done, and so that we can improve or kind of inform our practice. So it's my huge pleasure to introduce Arto and Juho Leinonen from Aalto University in Finland. Arto is a senior university lecturer who's been researching learning in digital and hybrid environments, and most recently with a focus on large language models. And he's joined by Juho, an academy research fellow who's interested in how AI can support and engage learners. And in their talk, they're going to be discussing their experiences of using Gen AI for their teaching tasks, as well as in the classroom. And they're going to reflect on the many challenges and opportunities of teaching and learning computer science with this incredibly rapidly evolving context of Gen AI models. And that's me done, guys. So, right, it's going to be over to you and we'll give you the power of the presentation.
I'm very, very happy to be here. Juho is as well. I heard about that earlier today, so he's also happy to be here. I'm just like telling it for him as well. So before we get started, let's do like very brief introductions. Maybe like Jane actually did like a really good job there already. So I'm a teacher at Aalto. I've been studying teaching, programming, and more broadly like learning in digital environments for almost like 15 years. I've been also doing a lot of MOOCs or like a lot of distance education, a lot of MOOCs and so on. And some of the courses that I've been involved with have been actually quite popular. So we've reached a bit more than 1 million learners. So that's kind of like one of the big things. I've been also like a university dropout. Then I went to the industry, but I ended up dropping out from there because it wasn't too much fun. So I ended up back in academia. So Juho.
And hi all, as Arto mentioned, I'm glad to be here. I'm an academic research fellow at Aalto University. So that's kind of like a research scientist type of position. Before that, I was worked as a postdoctoral researcher at the University of Auckland and University of Helsinki, where I also got my PhD in 2019. And I used to focus mostly on programming process data and analyzing that. But for the past couple of years, I've shifted focus to generative AI and large language models, and that's really studying how these could be used to support both students and teachers, and also building some educational tools that incorporate generative AI.
Yeah, so we'll very, very briefly discuss generative AI and LLMs before we go into our main bit. But so the basic idea with generative AI and large language models are that they're essentially machine learning models trained with vast amounts of data. So it's like this all contemporary AI and all contemporary machine learning methods essentially build on this idea that you have huge amounts of data, huge amounts of computing power, and then you use that to crunch the numbers and get something that really works in a neat way. So for example, GPT-4 has been rumored to have been trained with about like 13 trillion tokens, which is quite a bit of data. So what's typically happening is that this training is divided into two phases. So you have this pre-training part where the model learns a factual base just by training and learning to fill in content based on the text what they have or the data that they have, while in this fine-tuning phase that is followed by pre-training, they learn to answer in a specific manner by learning these input-output pairs. And what it practically looks like when you have something that works, and now you'll also learn my pronunciation skills. So please fill in the following sentence in the locations marked with Phil. Harry, Hermione, and Phil have their own unique characteristics, while Phil is a gentle giant. So that's a prompt. and then you might have a response. Harry, Hermione, and Ron have their own unique characteristics, while Hagrid is a gentle giant. So one of the interesting bits here is also that these vendors that provide these models, they always have also their own agencies and so on, but we're not really going in more detail into that. But if you have free time and want to see something funny, try looking into, for example, prompting models that have been trained in Chinese companies with the word Taiwan. But that's for the some other talk. So if during this presentation you have this feeling that, well, it's actually obvious that generative AI can do this stuff. By the way, that's like a generative AI generated image. It's clear. We understand you. So the funny thing that has happened really during the last couple of years is that we've been hearing news about this new kinds of AI that can do almost everything, and we've also come to expect a lot of things from these models. So, but like putting this into context, so when we started to look into this with Juho and our broader team, it wasn't really obvious. So we started looking into this somewhere in late 2021, and just to highlight this graph, so ChatGPT, for example, was released somewhere late 2022. One of the interesting bits is like Google Trends search. One of the interesting bits here you might also notice is that we have contrasted ice cream with GPT, and ice cream is less popular than GPT these days, which is sad. But what's actually really interesting, if you look into these patterns, when the ice cream thing peak goes higher, what's happening is that like GPT usage goes lower, and the same thing happens here. So when we have like this peak in ice cream, interest in ice cream, we have like this dip in interest in GPT. And you might wonder why, but that seems, I mean, we've kind of like figured out that, well, that's when people go to holidays, they're more interested in ice cream. And it's actually like this small dip here, this like winter, or like basically like winter holidays. So fun facts about ChatGPT and ice cream. And so what you can also infer from this is that if you want that your students do not rely as much on large language models, you definitely want to suggest like eating ice cream and stuff like that. Right, but this presentation, so we're looking into two sides of the same coin, so practice and research. I'll very briefly first discuss some of my experience from giving a class on software engineering with large language models, and then we'll go into research in more detail. And basically, this software engineering with large language models, we started like late 22, early 23, and I've given it about like 5 times already, right now is the 5th iteration of the course, and the content is basically like just like going from the language models and emergence of large language models to basically like creating an application where you land on the moon with large language models, and then there's like an end-to-end project. But like I'm giving this also as a cautionary tale. Like what we've always been focusing on also is emphasizing the role of communication and the need to understand requirements. But the key bit about this is, it's been also an open online course and whatnot. The key bit about the cautionary tale is that the world has been really strange. So in the last couple of years, I've been hoping that I could teach like whatever, like linear equations or something, because that hopefully, or it feels that doesn't change as much as these like LLM related contents. So I've given like 5 instances of these courses. The 5th is currently going on, and this is definitely like one of the fastest moving topics that I've given courses on. And like this is like from the perspective of a teacher who's writing materials. That's not fun, but I mean it's really fun, to be honest. So this a funny instance here that seems to be happening all the time is that whenever I'm giving a lecture, something happens just before the lecture. And this is like just a couple of instances, like somewhere early, a bit after the summer of 2023, there's like this communicative agents for software development. So basically someone, like a research team highlights that, hey, you can actually build a software development team out of LLMs, and then like these can build these small applications. We've also had like our news agency or Bauer Media announcing that, okay, well, news will be read by AI in a bunch of radio stations. And like even this fall, so my kickoff lecture for the 5th iteration of the course was on Friday the 13th of September, but on the 12th of September at like 11:17 p.m. I get this message like, hi, I'm pleased to share with you our new series of models, OpenAI 01, which was this chain of thought tuned model. And I was like, dang it, doesn't this end at any point in time? But like, just when looking back at these 5 instances, so just in a bit less than 2 years, what's really happened is that there's been first like early on, there's been a lot of hype but little tooling. But like right now, what's going on is that it seems to be almost this other way around. So there's plenty of tooling, but some of the hype has already died down. And what's really interesting is that people are really seeking for meaningful uses of LLMs. So it's no longer this like, well, we have LLMs and everything is solved. But now it's more about like, well, what's going to work, what doesn't work, what are the individual tasks at work that I could apply this into. But right, so let's go a bit more into research, because that's kind of like, what can we apply these into? That's been also has continuously in the software engineering with large language models course, is essentially like it's a question that's really good for research. So for this talk, we'll be focusing on 3 bits. So generating exercise with LLMs, using LLMs for responding to help requests, and learning to prompt LLMs. And at this point, I'm going to give the presentation rights to Juho.
I'm going to give you a presentation part of the presentation I gave at ICER, one of the top computing education venues, earlier this year, on generating programming exercises using generative AI. And this is actually one of the first use cases that we explored with Arto for generative AI late 2021, when we first saw this codex model that we were very impressed with. But this work uses GPT-4, which was the state-of-the-art model when we ran this study earlier this year. And here's the full research team on the screen. And to me, the biggest benefit of AI for creating programming exercises or any content really is that you can personalize it to individual students' interests and needs. So, in traditional courses, the teacher has to, try to keep it general enough that it's kind of interesting to all students, but probably not super interesting to any single student. Whereas here, when I was taking my first programming course, I would have probably been really engaged if all the exercises were about video games. Whereas Arto, for example, probably would have enjoyed exercises about ice hockey more. And similarly, you can target the needs of individual students. So if a student is struggling with loops, traditionally, you kind of hope that they will learn loops from the set of exercises teachers created. But with AI, you can keep generating new exercises on the go, on demand, depending on whether the student needs more practice for a concept. So we ran a study in one of Arto's classes, which is an online introductory programming course where the programming language is Dart. And it's mostly aimed for lifelong learners, so not university students, but anyone outside of the university who wants to learn introductory programming, where we had these AI-generated exercises. We opted here in the study to pre-generate them, and we pre-generated almost 300 exercises altogether. And we mostly did that because these large language models can be biased because they are trained with human data. And we wanted to make sure we are not presenting students anything that would be offensive, for example. So we did go through all of these before we gave them to students, and luckily didn't find anything super offensive there. And everything I'm going to discuss here could have been technically done on the fly, kind of on demand too. So how we implemented this is that we, at the end of these course ebook chapters, we added this new tool where students could practice with these AI-generated practice exercises. So in the tool, that students could choose out of 16 themes, then choose the concept that they had practiced in that ebook chapter and the difficulty of the exercise. They could also choose random if they wanted to. And these were just totally optional additional practice. Those students didn't get any course points for them. There was light gamification, so there's a progress bar at the top, and if you complete 3 exercises, you'll get a trophy. And in previous work by Arto and colleagues, it has been found that these progress bars can engage students, so they are more engaging, for example, than showing cat pictures to students. So students who saw cat pictures as a reward for completing exercise did fewer than students who had a progress bar. So this probably did incentivize students a little bit. And our research questions for this work were, how do us, the study authors, evaluate the quality of these exercises? And we'll call this expert evaluation later. Then how do students evaluate these? And then how do students interact with the tool where these were provided? And in the expert evaluation, we used a rubric that kind of focused on whether the exercise description was clear, matched the theme. So the theme could be, for example, pets or video games. In our original prompt engineering, we did find that if you ask for an exercise about pets, for example, it's almost always going to be about dogs and sometimes cats, but nothing else. So what we did in the background is that we generated subtopics for each theme. So students would choose just the theme of like pets, but in the background, we'd ask the model to actually, for example, make an exercise about fish or reptiles or cats or dogs. So we also checked whether it matched that kind of more specific topic. Then we also checked whether it matched the selected concept that the students wanted to practice, whether there were any concepts that were too advanced for that course ebook chapter, where it matched the selected difficulty, and then lastly, whether the thematic personalization was shallow or deep. And I'll show a couple of examples later, but basically shallow personalization means that there's maybe one sentence about the theme in there, but the rest of it isn't really contextualized. Whereas deep personalization, the task is a little bit more authentic, and there's more about the theme in the problem description. For students, we had a slightly easier rubric that just looked at whether the exercise description was clear, whether it matched the theme, because students didn't see the topic. So for example, they'd choose pets and not dogs. And then whether it matched the selected concept and the selected difficulty. Then after, if they did solve 3 exercises and got that trophy, we asked for a little bit more general survey where we asked them whether they found these useful for their learning and engaging, whether they found the theme selection satisfactory, and whether they enjoyed being able to select themes that match their interests. And what we basically found, so this is the results of the expert evaluation, and the main result is that, well, the exercises were very high quality. So in the vast majority of the cases, they were clear, the descriptions were clear, matched the theme, matched the topic, matched the concept, and very rarely included any concepts that would have been too advanced for that course ebook chapter. However, for the difficulty, we did actually find that most of the advanced difficulty exercises were actually too easy. So that choice in our evaluation, we found that didn't really make a difference in the difficulty of the exercises. And lastly, for the shallow versus deep personalization, we did find that most of the exercises were shallowly personalized. However, what you should keep in mind when I'm discussing these results is that for these last 2 rubric items, the iterator reliability was somewhat low. So even for us experts, it was kind of hard to categorize an exercise, whether it was kind of shallow or deeply personalized. But I'll still show you a couple of examples of that and how we categorize exercises. So here's an example exercise that was created with generative AI, and that we categorize as shallow personalization. So here the theme that the students would select was pop music, and the topic that they couldn't see which was there to or what was there to kind of increase the diversity was Ariana Grande, and the concept was arithmetics. And if you look at this exercise description, it says write a program that asks the user for the number of albums Ariana Grande sold in 2 different years, then print the difference between them. If the user enters numbers 3 million and 2 million, the program should print the number 1 million. Similarly, if the user enters the numbers 2 million and 3 million, the program should print the number -1 million, and then a couple of examples of how the program should work. And if you look at this, we see that the theme and topic are only mentioned in the first sentence, and the task also is maybe the most authentic task for pop music. Maybe music business would be more close to it, especially if we compare it to this other exercise that we categorized as deep personalization, where the theme was art, and the topic was Pablo Picasso, and the concept was conditional statements. And here the problem description says Pablo Picasso had different periods in his art career. One of them is the blue period from 1901 to 1904. During this period, he painted essentially monochromatic paintings in shades of blue and blue-green. Write a program that asks the user for a year and prints whether or not it falls within Picasso's blue period if the user enters any other year, the program should print the message not in the blue period. And then a couple of examples again of how it should work. And here we can see that the theme is present more holistically throughout the problem description, and the task itself also feels a little bit more authentic to art, kind of figuring out if a year is within the blue period. And we did find that the students kind of agreed with the experts in that they did find most of the descriptions were clear and matched the theme and the concept. And interestingly, students also found it matched the difficulty, which is a little bit different from the experts. Then for the more general survey, all students agreed that these were useful for their learning, and the vast majority also found them engaging, found the theme selection satisfactory, and enjoyed being able to select the themes. For the last research question of the study, so how did students use the tool? There's a lot more detail in the paper, but I'll just show you one example. So we looked at the logs to see what themes students actually selected in the tool. And although we can see that there are some themes that are more popular, like food in the first chapter and video games in the third, even the relatively unpopular themes such as literature and handicrafts were selected by some students, which can suggest that students do have varied interests, and it makes sense to personalize these exercises for students' individual interests. So the kind of key takeaways from this study are that students do want to choose a theme over just getting a randomly selected theme. And that was even though the thematic contextualization was often shallow. And in math education, it has actually been found that even this shallow contextualization can increase students' engagement and interest in doing exercises. Students also found these exercises engaging and useful. And in the expert evaluation, we found that these were relatively high quality overall. Now I'll give it back to Arto to talk about responding to students' help requests using LLMs.
All right, so thank you, Juho, responding to help requests. So this is a paper from 2023, also presented at ICER, where we essentially did what what the title says. So we really tried to look into, well, how well could it be used, or how well could these state-of-the-art or then state-of-the-art LLMs handle this task. And what we have in our platform is that we have basically like it's an online textbook with theory and practice interleaved, and there's like assignments where students can then type in information when they are typing code. When they submit the code for grading, they might get information that, okay, well, these tests didn't pass, after which they can request help. And when they request help, they are asked to type in information about their problem. Here this is like describe the issue. This is actually like a quite common issue, that the feedback tells me that the program is not working, but like what have you tried to resolve the issue? This is less common response, like nothing, lol. I'm just sending this request just to check if there's a human here. So once they submit the help request, what we end up seeing on the teacher's side is kind of like there's a queue of help requests that we then can respond to. So we see the code, we see the test results, we can go and look at the handout, and then we can send a response back to the student. So when we send the response, the student gets a ping on the platform. So this has been going on for quite some time, or a couple of years at least. So we've been doing this manually responding to help requests, which has also created a pretty nice knowledge base of help requests that we've been able to look into. So in 2022 version of this course, we had like about 4,247 students. So exactly about 4,000 students, 64 exercises, and about like 120,000 exercise submissions. Out of those submissions, only 833 actually resulted in a help request. And in this study, we looked into 10 randomly sampled help requests per exercise, looking into the exercises that had the most help requests. So basically, we looked into 150 help requests. We looked first into the actual issues that were present in the code. So this is an interactive programming course. And then we prompted LLMs. There was quite a bit of prompt engineering involved. Prompted LLMs to essentially provide a response that would help the students to solve the issue without providing a model solution. So in general, if we think about like help requests that we've seen on the platform. So quite a few of them relate to logic errors, so problems with conditional, problems with iteration, problems with arithmetics, and so on. But there are also problems like issues with input and output, including like formatting the output that is like maybe a bit strict automated tests, some unwanted printouts, again maybe a strict automated tests, and then again like missing printouts, so maybe students not really reading the handout and like looking into what the programs should also output. There's also a bunch of syntax errors, some very incomplete submissions, some dreaded problems with semicolons that prior research has highlighted that can take hours to fix. And then what we also observed, fortunately quite rarely, is that some of the assignments are also such that they have, like the tests have hidden requirements that are not in the handouts. And I haven't apologized personally to the students, but I should, because that's a bit of a pain. So, well, that's what it looks like on the data, but what happens if we have LLMs responding to the help requests? So what we did is that we crafted a bunch of prompts, but in the end we ended up going with a prompt where we had like information about the student's code, a question that primed the model to basically respond to the question, and also explicitly stated, okay, do not include model solution, corrected code, or automated tests, and so on. And so what we ended up seeing was about this. So this was done with GPT 3.5, which was the state-of-the-art model when we did this study. I mean, there's also a version in the paper that looks into Codex, and there's also both of these were done in English and Finnish if you're interested. But basically, what we found out is that GPT 3.5 was quite good at spotting logic errors, like very, very good at spotting syntax errors. There's like dreaded problems with semicolons and so on, and not so good at spotting these input and output errors, identifying at least one of those issues. Then when we looked into this, we also looked, so we basically categorized this into like, well, do they spot at least one of the issues? Do they spot all of the issues? And well, but about other issues. So whether these models pick up all of the issues is a slightly different story. So at least GPT 3.5 was pretty bad at picking all of the issues. And thus in some of the cases, it was almost as likely to point out non-existing flaws than to point out flaws that actually were in the code, which is pretty interesting in the sense of like at that point we basically decided, okay, well, no, we're not ready for this yet. So yeah, so this is one of the examples of just a simple program that's supposed to print the values in a list and like a snippet from that program. So the problem here is that the list initiation is wrong. So this should be like list length -1, and otherwise the code is fine. So GPT, when asked about this, there's a meaningful response. The variable I is inappropriately initialized. Its initial value should be list length -1. Unfortunately, because these models are excellent at creating content and they kind of like want to do that, the response also was followed by the next step. Like also you have an extra closing curly brace at the end of the code block. Remove that to avoid a syntax error. So possibly or potentially at that point, just the indentation here messed the thingy up. So the response was in this case highlighting that, well, okay, you should delete this curly bracket, which would actually lead to a syntax error instead of removing the syntax error. So just to highlight the key findings of the study from that point. So LLMs often already at that point detected issues correctly. So at least in most of the cases, or many of the cases, they LLMs did find at least one of these issues, and quite often also detected all of the issues. But they also hallucinated. So there was also like a lot of issues that were mentioned that were not present in the code at all. And even though we did prompt the models explicitly that, okay, do not provide a model solution, they did provide a model solution. So this is basically like GPT 3.5 was rather, I mean, it wasn't as good as following instructions as the more recent models. And interestingly, already at that point, like the model had no problems with Finnish. So basically, we were already at that point thinking that, hey, actually, we could then use these LLMs to help students in their language of choice. And at that point, GPT-4 was pretty much just released when we submitted the paper, which was again one of those like great moments. So we didn't have the chance to do this analysis with GPT-4, and well, at that point, it seemed that GPT-4 is better anecdotally, which, I mean, it's no longer anecdotally, but it is better. But we didn't do like a systematic analysis of it at that point. So one of the interesting things here is that, like, even though we did this analysis like in 2023, it's in some of these cases it might feel like, okay, well, these results from 2023 may actually feel ancient, which is like funny. I like in my career as a researcher, I've never seen, I mean, in my short career as a researcher, but I've never seen this happen. Like when you're like, oh, dang it, we did this like 6 months ago, and it's no longer, it's no longer valid. So this is kind of like a funny thing. But to us, when we were doing this, it clearly showed that there is promise for this. So as these models are improving, we're definitely going to see this work. So back to Juho.
Talk to you a little bit about teaching students to prompt LLMs. So why teach prompting? So also at ICER this year, we had a paper that we call The Widening Gap, the Benefits and Harms of Generative AI for Novice Programmers. And basically in this paper, we replicated an earlier study that looked at what types of metacognitive difficulties do students face when they are programming. And the study we were replicating was done before generative AI, and we wanted to see if these maybe generative AI has now helped and students don't face some of these metacognitive difficulties anymore. So the original study did find 5 different types of metacognitive difficulties, forming the wrong conceptual model about the right problem, then dislodging, which meant that if you have an incorrect conceptual model, it might be that you are kind of stuck with it and it's hard to dislodge that. Then forming the correct conceptual model, but for the wrong problem, and then location, which was kind of moving too quickly through the problem-solving stages, so that kind of leads you to a false sense of accomplishment and poor conception of where you are in the problem-solving process. And achievement, which was kind of unwillingness to abandon a wrong solution due to false sense of being, almost there, nearly done, so you don't want to start all over again. But unfortunately, when we replicated this, we did find, well, actually, all of these 5 metacognitive difficulties from the prior work are still there, and especially for students who are struggling, some of these are made worse by generative AI. So for example, location, it's now a lot quicker for students to produce code, so it's a lot faster to get to to what you think you are now at the end of the problem solving process, because you have tons of code, but maybe it's totally wrong, and then you kind of that makes both the location and achievement metacognitive difficulties worse. And we also found that there are new types of metacognitive difficulties that students now face when they are using generative AI. And we found 3 different types. So one is that one we called progression, where we basically saw that students are really behind in the course material, but they don't realize that because they've kind of used generative AI as a crutch. So they've kind of been able to submit correctly working exercises even though they don't really understand the code. Another is interruption. So if you're using a tool like GitHub Copilot, it always suggests you new code if you take a break for even a couple of seconds. And we did find many students are kind of interrupted, or their problem solving and thinking is interrupted by a new suggestion from the AI tool. And then lastly, a mislead, where the generative AI tool might lead the users down the wrong path. So for example, maybe the student writes just a function name, and they get the suggestion from Copilot, they accept that, but it's actually solving the wrong problem, for example, and then they just keep accepting solution or code suggestions that kind of lead them down this rabbit hole of solving the wrong problem. And one kind of concrete finding that we did find is that those students who are already poised to succeed were able to leverage generative AI to accelerate. So they would, for example, realize that, hey, this code suggestion is wrong and ignore it, where students who were struggling might be hindered because they might accept those solutions and they might be left with an illusion of competence. So so we think that it would be important to teach students how to use and prompt these generative AI tools so that they can all learn to leverage them productively. And one way to do that are prompt problems. And this is a paper from SIGSI this year. And if you were here in the April seminar, I think Brett Becker talked about this a little there. I'll also show them to you now. So basically we've created a new type of a programming exercise that we call prompt problems, and a tool where we can show this to students. And in prompt problems, you basically get a visual representation of a problem, and the student is then supposed to write a prompt that would generate the code to solve the problem. And we went with visual representations because if it was textual, the students could just copy that problem description, send that to the model, and often they would get the correct solution. So here they still have to think about the problem and be able to verbalize it and kind of articulate the requirements. And that's also, we think, something that professional programmers do often. They kind of discuss with a client and then they have to think about the requirements and the edge cases themselves. So here, once the student has an idea, they'll write a prompt and send that to an LLM, and then they will be shown the code that the LLM generates based on their prompt. And that code is then run against unit tests to give automatic feedback for the students. In this case, all the tests pass, but if any of them failed in the original traditional prompt problem, students would need to go back to their prompt and edit it and try again. So here's some feedback that we have gotten from students. So students commented on this being a great way to get exposed to new constructs. So they, for example, said, these exercises introduced me to new functions. So this method of writing code could help increase my programming vocabulary. Another student said the main benefit I gained was observing the logical structure of the programs that it created. In all three cases, it used functions that I was previously unaware of, allowing me to gain an understanding of how they could be used and the correct syntax for implementing them. Students also found this helped them with their computational thinking. So they said stuff like, I think while writing prompts for AI, we actually have to have a clear logic to break down the question and explain in plain words. Another student commented, I do think that writing prompts for code is a good way of developing analytical and problem-solving thinking and skills, as it forces you to think through the steps needed to take the input through to the output. However, not all the feedback we got was positive, so there's also some negative feedback. So one student said that you have just ruined every piece of self-esteem I had regarding coding. I know full well that it would have taken me around 35 minutes to figure out how to create those functions, and that damn computer did it in seconds. Robots are going to own us within years. Another said, I found it to be a frustrating and unpleasant experience. Much of the time, the generated code was failing due to problems that could have been easily fixed with direct edits, but I had to fix the problems in the prompt instead. And another said, it was medium difficult to specify the problem that I wanted to solve. There were special cases where the prompt can give me the correct answer, but generating a new code with the same prompt can give me an incorrect answer. Therefore, I had to go into more detail to solve the problem. So we've taken these negative feedbacks to heart, and I'll show you a couple of experimental versions of these prompt problems that are currently under review that we kind of have explore and research. So first, about being easily fixed with direct code or direct edits to the code. So we have deployed a version of these prompt problems where students were able to edit the code or go back to the prompt. And this figure shows that the x-axis is basically the number or the prompt number. So 20 would mean that the student has done 20 prompts at that point. And on the y-axis, we have the percentage of likelihood kind of whether they would edit the code directly or go back to the prompt. And we did find that in all cases, in under 25% of the cases, students would go and edit the code. So they really liked editing the prompt more, which might indicate that they might be over relying on the AI, or at least they prefer writing natural language compared to editing code. We can see the trend that it's a little bit more likely to edit code in the beginning, and then maybe then again at the very end, if you have already tried 40 prompts and it's still not working, maybe at that point you're like, okay, I'll edit the code instead. Then the other experimental version that we've tried is, so basically these LLMs are non-deterministic. So there's some inconsistencies. So sometimes a prompt might lead to correct code and sometimes incorrect code. So another version that we've trialed is where we also try to measure the robustness of the prompt. So instead of just generating one code from the prompt, we will generate 3 different implementations and run all of those against the tests and give students feedback in this in the form of these stars on how many of those 3 solutions pass all the tests. So in this case, all the 3 solutions that we generated from the same prompt pass the tests. But it could be possible that, for example, if you have a brittle prompt, it would only generate the correct code once out of the 3 implementations, and we would give that feedback to the students, and we can hope to nudge students towards writing more robust prompts with this type of feedback. But this is hopefully coming out sometime next year, the paper on this. And I'll give it now back to Arto to kind of draw all these streams together for the ending of this presentation.
Right. So very briefly, so what we've seen is that we can use LLMs to generate exercise. We can use LLMs to respond to help requests. What we can do or use LLMs is to teach prompting with them. And I mean, it's essential because it's generative AI. It can generate content. So it's really up to us to come up with ways to use these tools. So it's really we can if we can think about it, we can probably like have these models do it to some extent, especially as there's been like significant improvements in model performance over the last years. So one of the big questions that we have is like, what's next? It's going to take just a couple of minutes. So this is like a picture that Juho took from my lecture, like maybe like 10 years ago. So highlighting this classic view of like preaching to the masses. I mean, it's really from 3050s, but it's still a university lecture. This is a different take of lecturing. So this is actually the Pope giving a sermon on a baseball field from 2010 something, which highlights this one phenomenon that we've had. So basically MOOCs. And this is kind of like one of these potential futures that we might be seeing. So a happy kid with a robot, and it's a good question whether this will happen, say 2030 something or late 2020. So this is kind of like culminating this intelligent tutoring systems research and this like using generative AI as supports and so on. But there's a slight problem here. So there's a question about the community. So this is an old picture from the University of Helsinki, where we have this thing called extreme apprenticeship. We're really kind of like looking into building the community. It's from a class in mathematics, where it's basically just like your average walk-in campus support lab. So the environment was built so that you can basically do math everywhere, so that you could draw on the tables. You had people helping you out. So this basically like TAs there, and you had also apprentice teachers who were basically growing to be a part of the community. And this is not a fake shot. So these students were really collaborating, and it was basically like it was really a vibrant community. But if we're going to go towards a situation where we're going to have more and more of these AI tools present helping us out, what's happening is that we're going to lose some of this community. And basically, at least in my work so far, I've been looking a lot into automating support and so on. Whenever we introduce some sort of automated support, whenever we introduce kind of like computer mediated ways to support the students, we're always kind of like losing a bit of the community, because there's less people who need to come to the campus, who want to come to the campus and so on. So maybe as a question for the next breakout room. So how do we foster an active community of learners in the generative AI era? So thank you.
So can we give Arto and Juho a big round of applause, or a big virtual round of applause?